Hello, today we're going to talk about point slope form. So to start, I have a little intro here. So what I'd like you to try on the top of your paper, so we're going to do a whack today. This is going to be part of your notes for what you need to complete for this to turn into me tomorrow when you walk in the door, is we're going to write the equation for slope on top of your paper. So it should look like that. Here's your paper. There is your slope formula. Don't forget to set it equal to m. Alright, now what I want you to do is multiply both sides of the equation by the denominator. So I'll give you a second to do that. This is the denominator, so multiply both sides by x2 minus x1. Alright, hopefully it looked like that. Okay, so what are we going to have left? So what's going to happen to this left side of the equation? What's going to happen to this numerator and that denominator? Hopefully you realize they cancel out. And I'm left with y2 minus y1 equals m times x2 minus x1. That's pretty much point slope form. We've got to make a few changes to the y2 and x2. So let's take a look. All right. Point slope form, chapter 6, section 5. Here are the pages you're going to want to look at if you're having any trouble. And our essential question for the day: how can I write a linear equation when I'm given the slope of a line and 1 point? So we're going to be writing equations, we're going to be graphing equations giving the slope and 1 point, or sometimes 2 points, because we can take 2 points and find the slope and then use one of them to write this equation. So that's what you're going to do at the end of the lesson today. Alright, so here is official point slope, y minus y1. So here's, remember, we're only given 1 point in this equation. Okay, so we'll have one y value, one x value, and we'll have the slope, and we're going to simplify this equation to write an equation in slope-intercept form. All right, y minus y1 equals m times x minus x1. So you'll have three of these values: the y1, the m, and the x1. This will just be part of our equation. That's the y-coordinate, that's the x-coordinate, and that's the slope. And notice the formula has minuses, just like your slope formula. It's basically the slope formula. Okay, and that'll come into play when you're given negative y or negative x coordinates. Okay, so we're going to start with a graph. All right, and the first thing I want you to notice about this problem: this is a level 1 problem. This is as easy as it gets. Okay, because our original formula, if I go back, had minuses in it. All right, and so does this formula. So I know that the x-coordinate is actually 1 and the y-coordinate is actually 2. If these were x plus or y plus, then these actual points would be negative. All right, because when you subtract a negative, you get a positive. So if you ever see a plus here, know that that sign is opposite. All right, but the first thing we're going to do is what point is given in the equation. It's 1, 2, 1 comma 2. All right, that is my coordinate. And again, these are positive because the formula starts with minus. We haven't changed anything in the formula, so we're not changing these values. 1, 2, and you put your plot over 1, up 2. Now we're going to use the slope to find a second point. The slope is 1/3, which means I go up 1 and forward 3, and then you connect your dots. So that is example 1. All right, let's take a look at example 2. Now we're actually going to be writing an equation. Okay, so we're given the slope, it's negative 2, 2, and our point 3, negative 3. Here's where we're going to see how that sign change works. All right, so we start with our point slope formula, and I'm going to fill in these numbers. The negative 2 is going to go there, the x-coordinate 3 is going to go there, and the negative 3 y1 value is going to go there. All right, and notice I use parentheses around my y coordinate. All right, and make sure I don't leave off one of these minuses. All right, so I'm going to simplify. So I'm solving for y, and that gives me y plus 3 equals negative 2x plus 6. Again, two negatives make a positive. So if you went back to example 1, if you saw a plus 3 here, you know that was actually a minus 3. And there's kind of an explanation of why. When you subtract a negative, you're really adding, and that changes the original formula. Okay, and when I subtract 3 from both sides, 6 minus 3 is 3, so I put it into slope-intercept form. Read the directions. Some problems are different. Some problems will ask you to stop at slope-intercept. I'm sorry, at point slope. Some will ask you to go to slope-intercept, and some maybe even might ask you to go to standard form. So I would add 2x to both sides, get 2x plus y equals 3. So we could do all three of those situations. All right. Now, example 3. This is the one that you're going to try on your own. It's a little more difficult, but I do have the steps. So this is what I want on your paper after the attempts here. So this is your attempt. So we're going to be writing an equation in slope-intercept form for a line that passes through the points -1, 4, and 2, 3. So the trick here is they're not just giving us slope. Okay, we have to find slope ourselves. So we got to find the slope, y2 minus y1 over x2 minus x1. All right. You have to pick one of these points. It does not matter what point you pick. Okay. You could pick this one. You can pick this one. In the end, you'll get the same answer. You're going to use point slope form. So y minus y1 equals m times x minus x1 with one of these points, not both, just one. And I want you to put your answer in a slope-intercept form. So some of you are going to pick this point, some of you are going to pick that point. In the end, when you put it in slope-intercept form, you will all have the same answer. So this is the one I want you to try. These are the steps I want you to do to try it. Good luck, and we'll see you guys next time.